Okay, class, today we're going to talk about half-life, which is found in Chapter 10, Nuclear Chemistry. Let's get started. So half-life is defined as the time it takes for 1/2 of a radioactive isotope to decay. So half-life is a time. The half-life of a specific radioactive isotope is constant, meaning those radioactive isotopes that have a known half-life will always have that same half-life. It doesn't fluctuate or change in certain conditions, and that's how they're able to use radioactive isotope half-lives as a measuring device to learn how old things are, to predict things that happened in the past, such as carbon-14 dating. And they also use it in other ways, such as in nuclear pharmacy and radioactive tracers. So we can determine the amount of radioactive isotope remaining after a given number of half-lives by using this expression. Okay, now you don't have to memorize this, but you do need to know how to use it for exams, and you will want to know how to actually, plug in superscripts on your calculator, such as that. So it's the amount remaining equals the initial amount times 1/2 raised to the n, okay? And n being the number of half-lives. So here's a graph showing you how half-life works. So at t equals 0, so your initial time, you have 100 grams of substance. And then the time it takes to get to half of that amount, so you go from 100 down to 50 grams, it took 12.3 years. So 12.3 years is your half-life. Now, if you double that year amount and you get to 24.6 years, you just encountered another half-life. Okay, so now you're down to 25 grams, then you go down to 12.5. You add another 12.3 years to it, add another 12.3 to get to 49.2 years. You're down to 1/2 of 12.5 being 6.25. And notice that in each half-life, it is decreasing by 1/2 of the mass remaining. And notice that for every given half-life, the time it takes is constant. At every single half-life, it takes 12.3 years. 12.3 more years, 12.3 more years, so on and so forth. So for this particular substance, 12.3 years is the half-life because it's the time it takes for that particular compound to decay 50%. So let's check out an example using that expression we learned earlier regarding half-life. So the half-life of phosphorus 32 is 14 days. Okay. The half-life of phosphorus 32 is 14 days. After 70 days, the amount in your body is 67 millicurie, which is a unit for nuclear chemistry. What was the initial amount of phosphorus 32 in your body? So we are solving for the initial amount, which is right here. And so let's plug in values, okay? So we know that we had 67 millicuries after all this decay has happened, okay? So the half-life of phosphorus 32 is 14 days. Now, here's a mistake students like to make. They like to think 14 goes right here. But actually, n is the number of half-lives that have passed over this given amount of time. And so what you're going to do is actually take the number of days, which is 70, and divide it by 14 to get the number of half-lives that have passed. Because we know that we have waited 70 days, and for every 14 days, you get one half-life. So let me just write that. N equals number of days over half-life, where n equals number of half-lives that have passed. And you get that right here. So 70 divided by 14 should give you 5. So after 70 days, it has encountered 5 half-lives. So it's gone down by 1/2, by 1/2, by 1/2, by 1/2, by 1/2. Hopefully I did the math right. Hopefully that was, or counted right. I think that was 5. So anyways, so let's set up our equation, okay? 67 millicurie equals x, because we don't know the initial amount, times 0.5 or 1/2 raised to the 5th power. So what I'm going to do is I'm going to go ahead and do that in the calculator. I'm going to put 0.5 raised to the 5. So that's what I typed in my calculator, 0.5 caret and then a 5. Okay. Or, that's the way I would type it in. So that's what I encourage you to do. And what I got is 0.03125 And now I'm going to take 67 divided by that number to isolate the x term by itself. 67 divided by my answer gives me 2,144 grams. Not grams, excuse me, millicurie. Like I said, that's a unit used in these types of problems. And then you can always check your work. Did I do that right? So let's say that let's say that I was looking for my amount remaining. And so what I'll do is 2,144 millicurie times 1/2 to the 5 and see if I get the 67 that I was looking for. 0.5 raised to the 5 times 2,144 equals 67. So that's your answer. Good. So we did that one correctly, and that's how you use that equation. Here's a problem that you'll find on sapling. And I just wanted to go over this very quickly so that you know how to do this. So actually in sapling, you won't see these lines. I drew those in for you. So let's act like they're not there for now, just so I can teach you how to do this. So what is the half-life of this sample? How many days correspond to 50% of the sample left? So look at the sample remaining. We are at 50 right there. So you just simply draw a line across. And then it tells you right there you're at about 74, 75 days. And then if the initial sample is 15 grams, how many grams remain after 130 days? And there's a couple ways you can solve this. I like the formula. It's kind of foolproof. So we know that the initial amount, 15 grams, goes right there. And we know that the half-life is 74 days thereabout, and it took 130 days. So we'll do x equals 15 grams times 1/2 raised to the n. Now remember, n is going to be the number of half-lives, so we waited 130 days. And the half-life was, we'll call it 74 days. So n is going to be 130 divided by 74. And we get about 1.76. And so now I'm going to do the math. 0.5 raised to the 0.76. Sorry, to the 1.76. Got about 0.295 times 15. So I got 4.43 grams would remain after that 1.76 half-lives. And hopefully that makes sense. Half of 15 is going to be 7.5. And we went almost 2 half-lives. And so hopefully that amount makes sense, okay? Another thing you could do is you could have found the 130 on the graph, went up, and found that that corresponds to about 30% of the sample remaining. And so you could have just taken that 30% divided by 100 to get it into a number, to get 0.3, and then multiplied that times your initial amount to get the amount remaining, 0.3 times 15. And I got 4.5, which is almost the same as that. The reason that's 4.5 and that's 4.43 is because maybe I estimated that incorrectly. Maybe that should have been 75, and just rounding errors would have changed a little bit. And yeah, so you don't need to know this information for exams and quizzes. That takes care of the information I plan to cover today. Y'all have a great day. Bye-bye.